Hello, I wanted to walk through the design that I've been working on. I had the first kind of teaser video out, and I thought I'd walk through some of the parts and the thinking I was going through. This is the basic wheel hub. I listed the part number and the automobile that it went to, but it was nice because it had the wheel studs and it also had threaded holes in the back to mount threaded rods to. So on each axis or point of rotation, I had a mounting point. So this is it measured and just rough. I just made it out of shapes and such. So let's throw a stepper motor on it. I decided to go with a NEMA 17 with a 100-to-1 gearbox on it. I calculated the spacing from center to center, and I went with GT3 belts. I did not go with GT2. I thought GT3 was going to be much beefier, I guess. The teeth are much bigger, so I thought chances of this actually succeeding would increase by going with GT3. Let's see. This is the actual bracket that I designed, and then the motor sleeve is what the motor goes into. So what this does, you'll see this motor sleeve is able to slide back and forth inside this void. I have M3 metal shafts running through it to keep it square, and then M3 bolts to move this, what I call motor sleeve, with the motor in it back and forth. Let's see if we turn off the bracket. I am using heat set threaded nuts that the M3 screws will go into, and then obviously the M3 rods, they just slide back and forth to keep things square. So let's see, let's go ahead and turn off the bracket. We'll turn on the body. I designed the body up and around the bearing. So you can see inside where I've left areas to where the bearing is going to fit in there. Those are the wheel studs, and I'm just modeling around 3 of them for right now, or at least designing around 3. I probably will do all 5 wheel studs on this is what I consider the right ascension axis. So we can leave those on actually, why don't we? So this is the body that I designed out in Fusion 360. It will be 3D printed. And the threaded rods are going to come through the 3D printed body like this. So the threaded rods go up into, if we turn off the RA body, up into the base of the bearing and come down. So we'll turn the RA body. Now here's where things get, well, let's go ahead and show gears. This is the GT3 gear that I designed that is 3D printed. And then I have a 16-tooth, I'm not sure if I have that in here or not. But anyways, there's a GT3 16-tooth gear that I purchased on the motor. So let's see, let's go ahead and turn the motor bracket on. So everything is turned on now as far as the right ascension axis. Now here's what I found. You know, right ascension is going to be like this. So what I found was this majestic geared head used for photography, and it's pretty beefy. It's about the only thing I would trust to, because right now the way I've weighed it, this whole assembly, once I'm done with this, when I show you the final video, is at 17 pounds. So the weight is starting to climb. And so having a heavy duty base for this telescope is going to be very, very important. So how do I attach it to this base? Well, what I decided to do is plastic 3D print is not going to cut it, so we need to throw some more metal at it. And so what I did is a bottom, a side, and this is going to be, this is modeled in approximately 1 inch by 3 inches, no, 1.5 inches by 1 inch. Mild steel square hollow tubing that I found. So I bought some of that, and I have a welder, and I dabble a little bit. You will see I'm not very good at welding, but I can make metal stick together. I will be revamping some of this. Now, this is not what I actually designed. Once I got a hold of the actual metal, it's hollow square tube with it's about 1/8 of an inch thickness of material. It's hollow, and once I got the actual steel in my hand, I decided I was going to go with 1 inch by 1 inch, 1/8 of an inch thickness square tubing. So in the video that I show here of the final product, you'll see that's what this design evolved into. So I need to update my 3D model. So that was how I was going to attach, I made a plate that replaces this plate here on the tripod head, and I welded that plate to the 1 inch by 1 inch steel tubing. So that is how it is attaching to this tripod head. And obviously on this threaded rod we're using nuts and lock washers. Okay, so I will show real quick Declination, and this is super rough. Declination, I just modeled it out. Right now, right ascension, I'm pretty happy with what I have so far. So Declination, let's turn off, it kind of gets in the way, we'll turn off that tripod head. You can see what I kind of did is I started with a cylinder to attach to, or fasten to, the wheel bearing. And then I copied up some of the same bodies from right ascension up to Declination. Now, this is still rough. I still need to get an idea of strength here. I most likely will have to have, I'm going to have more metal in here. 3D printed parts are not going to cut. A lot of this 3D printed parts is there to surround the metal and keep it square and keep it straight. If we take out the body, and let's see, Declination will take out the body. Oh, I don't have any threaded rod in here. But you can see wheel bearing. Eventually there's going to be, I thought I had threaded rod, but maybe I've lost it in my, I need to get more organized. So wheel bearing, threaded rod through, and then wheel bearing, threaded rod, welded steel. The 3D printing is going to essentially wrap a lot of this and keep a lot of this threaded rod and steel aligned. And now this is going to be, Declination is going to be the same kind of idea. Let's see, not wheel stud. We want to put the RA body back on. And we can turn on the GT3 gear for declination. So that is kind of what I'm roughly aiming for. We'll have declination rotating around this bearing. We'll have the actual telescope rotating around this bearing. Now this is still up in the air. The type of dovetail that I'll be using, I do not know. I most likely will buy one from, I think, shoot, there was a dovetail I was looking at, ADM, that makes rings and plates and astronomy gear. They had a dovetail bracket that I liked. So most likely I will be buying an ADM dovetail plate to put the telescope on, and then I'll figure out a mounting system to actually attach the ADM dovetail to this thing. So like I said, right now we are at 17 pounds, just RA. That's motor, printed 3D printed parts, threaded rods, steel welded assembly, and the tripod head with a geared adjustment, so I can adjust that back and forth. So let's show the video. Okay, so here we are. I have it set up here on the table, and I have it hooked up to a Wemos with a CNC on-step computer. You can see the GT3 belt. You can see the motor here. It's a 100:1 gear ratio NEMA 17. And there's the wheel bearing. So as it's rotating here, this is at maximum speed that I have it right now. I haven't really fine-tuned a lot of the on-step settings, but I could probably increase the speed once I got into the smart web server. You can kind of see here the adjustment block that I made, that you can turn those M3 screws and nuts, and this motor slides on those 3mm rods. And then this is my welding, so don't look at my welds, they're really awful, but I probably will be redoing this. This is a rough. You can see the 1" by 1" square steel tubing. Approximately it's 1.12 thick, almost 1/8 of an inch thick. I did a base of, it's about 1/4 of an inch thick, and then the threaded rods with the lock nuts, I don't have it all fastened up. I wanted to make it, see it run. So it's coming together very well. Everything's running pretty smooth. I will be looking at how this is looking, how this is running. Right now this is all printed in PLA, just for cost savings. The final product will be printed out of PETG, most likely. But you can see for scale, there is the Wemos with the CNC, lug nut. So it's pretty beefy. It's pretty good size. What it will carry, I have no idea right now. This is just an experiment, and it's something to play with, and I'm having fun doing it. And so this is the current state of it. So we'll just call this, and say this is where it's at. If you have any questions, leave them in the comments. We will talk to you later.